This is lab 2 or lab E2 part 1. Here is my teammate Rahat and this is me, Lim. Currently at the lab E2 part 1, all the D input is turned off, clock input is turned off, and the Q output is off. For the clock input, we did due to the flow of the clock input, we decided to switch it to the switch module. Currently, according to the D input, D is turned on right now, and then we switch on the clock input just for a short press. Now the Q register, the Q is on. Then we turn off the D input, Q still remaining on. Next, we just press the clock input without turning on the D. Now Q is off. Furthermore, it's only D is turned on for a short while. When D is turned on, Q did not turn on without any clock input. Lastly, when D is turned on into infinity, and then clock input is also turned on to infinity, the Q output is light up. Okay, this is lab E2 part 1 and it is the temper detection circuit. At here, the VCC is connected to the chip and the ground is connected to the chip. This long white wire is connected to the output. This white wire on the top is connected to the S bar, and this white wire at the bottom is connected to the master reset. The D wire is connected to the D input, and the blue wire is connected to the clock input. At here, the temper detection circuit, the switch for the master reset, the D input, and the S bar is toggle on, and when the equipment is disturbed, as the clock input when the equipment is disturbed by the clock input, the output is lit up, and even though the disruption is already ended, the circuit still remember that it is tampered with. Afterward, to reset the circuit, we just press the master reset and then toggle it on again for another round. Okay, currently we are doing the lab E2 part 2. At here, from the orange wire, it is connected from Q bar to D, and the Q output is connected to the switch module. Yeah, I think that's everything. Okay, The R bar and the what again? S bar is disabled by connected to the VCC. Right now we are setting the clock input to 500 kilohertz. Okay. Okay, now the clock setting is set to 500 kilohertz and the result will be shown in a oscilloscope. Okay, this is the image from the oscilloscope, and here we can see that the waveform of the clock input is half of the waveform of the S output. So therefore, the if the frequency of the clock input is 500 kilohertz, then the frequency of the S output is half of it. So divided by 2, then it will be 250 kilohertz. Okay, this is the Lab E2 part 3. First of all, we connected the clock input to the clock module, currently running at 2 Hz. So the number is changed every half a second. And right over here, this orange wire is connected to the CEP and the switch. It connect the switch module to the CEP to enable the counting mode. So this would be our run and stop button. And as we can see here, the button, the LED module is over. It's from this direction. Okay. 1, 2, 3. 1, 2, 3. Oh. Okay. Now it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. As for the question inside the lab sheet, does the number appear to be random? Okay. The number is not random, it's just that when the hertz, the frequency is turned up to higher frequency, it will be faster and faster until the number indicated by the LED module appears to be random, but it's not actually random, it's just counting very fast from 1 to 6. Another situation is that when the frequency is very high, the LED module will appear to be the same number. So the frequency is so high that the LED module does not have enough time to respond properly. Okay, let us reset the frequency. Yeah. Now, when it turns out to lower frequency, it goes from 1 to 6. Okay, 1, 2, 3, 4, 5, 6, and go back to 1. Now to kill the run stop button, when this one is if I want it to stop at 6, okay, wait for the number to jump to 6. Okay, I press the run stop button and the number itself is stopped. The counting is stopped. And then if I turn on the run button again, I toggle it on, press it for a little while and it is toggled on. Now the counting mode is re-enabled again and it is counting from 1 to 6 again. Okay, testing one more time for the run stop button. Okay, now it stopped at 2. I toggle it on 3, 4, 5, 6. Oh, a bit late. Okay, 1, 2, 3, 4, 5, 6. Okay, now this is Lab E2 Part 4. For this part, we use two quad 2 input NAND gate chips. Okay, so this is 74HC00. This one also 74HC00. Yeah. The chip at the last is not used in this circuit. Okay, first of all, we are going through the table given. So counting from 1 to 6, the first one give a die row, and the die module only one is lit up. The second 2 is only 2. Okay, 3 give 3 die value. Okay, 4. Okay, next one 5. Yes. Okay, last one 6. Yeah. Okay, so at here, this one, the very last one is connected to Q0.
Number 5. Yeah.
This one is connected to Q1, and the last one is connected to Q2. Okay. Okay, that's all. This is Lab E2 Part 5. Over here, this chip is 74HC161, and this 2 is the NAND gate 74HC00 chips. Okay, here, oh, it looks, this wire connected to this one is the clock input, and the output is all connected to the die module A, B, C, D. Okay, starting at first clock input, the die displays 1. At the second clock input, the die display 2. The third clock input, it is 3. At the fourth clock input, it is 4. Fifth clock input, it is 5. And the sixth clock input, it display a 6.